Hi, in this video we are going to learn about Discrete Memoryless channel. It is Sridevi, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. On completion of this model, the learners can able to understand the concepts of discrete memoryless channels. We know that the performance of communication system is measured in terms of error probability, and error transmission is possible when probability of error is at the receiver that approaches zero. There should be no probability of error, then only we can tell that is errorless transmission. Each communication channel is characterized by the relationship between input and output. Simply, throughout the analysis we consider the discrete time channels. According to Shannon's sampling theorem, if the channel bandwidth is limited, we can consider its samples, and then we can assume that the channel is discrete in time. So the performance of the system depends upon available signal power, channel noise and bandwidth. Based upon these parameters, it is possible to establish a condition for errorless transmission. The sampling of the stochastic process. Stochastic means the time that is the process yields at the input of the channel the sequence of random variables x of k and nt that depends the time. So the discrete time signal, the input sequence is the sampling of stochastic process x of k and t with the sampling step t. So let us consider the input signals x1, x2, x3 are different processes which is given as the input of the channel. The capacity of the channel is determined by C, and this channel produces the output, that is y1 is the output of x1, and for x2 it produces the output as y2, and x3 it produces the output of y3. So the complexity below which the signals cannot be compressed. So the information theory is used for mathematical modeling and analysis of the communication system. This theory is modeling for communication system in main 2 points. So the transmission rate for reliable communication over noisy channel. So and simply the discrete memoryless channels, the noiseless binary channel which is represented as the channel having binary input is reproduced exactly the output, that is called as noiseless binary channel. It can be possible by using the coding theorem, channel coding. The advantage of this coding is error probability is reduced, and errors are detected and corrected. Excellent channel coding techniques are available that minimize the chances of errors. So probability of error P for noiseless binary channel is P is equal to 1, 0, 0, 1. This is the limit case for which have no longer a probabilistic channel. So the binary symmetric channel is a binary channel in which the input symbols is flipped with the probability of is sigma and 1 minus sigma. So 1 minus sigma and 1 sigma are represented as 1 minus sigma as the diagonal elements, and sigma like this binary symmetric channel. This channel it is used frequently in communication engineering without loss of a condition with the epsilon or a summation is less than 1 by 2. Whenever it is greater than 1 by 2, it can trivially reverse the input symbols, yielding an error which is lower than 1 by 2. That is binary erasure channel, that is represented as P equal to 1 minus alpha and 1 minus alpha in the diagonal and 0, 0. This channel is similar to the binary symmetric channel, but in this case the bits are lost, so that it is rather flipped with the given probability alpha. The transmission matrix of B binary erasure channel is P is equal to 1 minus alpha, 0, 0, 1 minus alpha. A channel a channel is the same as above QRA channel. So QRA symbols at the output of the detector Q is greater than or equal to small q. So the probability y equal to yi at x is equal to xi, that is yi given xj, yi given xj, I equal to 0 1 etc up to q minus 1, j equal to 0 1 etc up to q minus 2. The channel, such a channel is called as discrete symmetric channel, and P is the transmission matrix of the channel. The channel coding theorem is used for coding this type of channels. All these coding theorem techniques are add redundancy bits in detection and correction. So transmitter side this bit is added, and the receiver side it is removed. This increases output data rate and reduce wide bandwidth. So simply this discrete memoryless channel is for the transmission of information from transmitter to receiver. And we have one quiz question here. The binary symmetric channel is a discrete memoryless channel, continuous memoryless channel, discrete memory channel, continuous memory channel. The answer, we know that as we know earlier, the binary symmetric channel is a discrete memoryless channel. So A is the correct answer. Thank you.